panelists, if you're here, I think there's going to be a point. I'm going to try to do some teaching. So if there are panelists on here, there'll be a point where I'll ask you to turn on your video and unmute. And so we can do a little bit of science. That's my intent. I think a lot of teachers like myself are trying to figure out, how do we teach in this new platform? I know that I've changed a lot of what I've done from the first Science is Cool conference. And so let me, if you would, bear with me. This is that awkward time when you try to figure out how to share your screen. But what you should see is a picture of me. This is me back in the day. So this is in my classroom in Montana. This is before my first day of teaching. So this is 26 years ago, to date myself a little bit. I had no idea what teaching was going to be like. All I did was just survive that first day and then make it. And so the big thing, I guess, I'm feeling right now, and I'm sure other science teachers are feeling right now, is that I'm feeling like a first-year teacher again. So as we've had to go remote, we're out of the classroom, we don't get to see those kids every day. I'm like having to reinvent myself as a teacher, and I know a lot of you are probably struggling with that as well. And so back in the day, there were two things that you had. There was you, and then there was the files that were in the file cabinet that you had, all your work. Right now it's kind of in Google Drive. And so the one thing that I want to kind of talk about is that the most important thing that you'll see today is people. It's not about the resources you use. I hope you picked that up from Neil deGrasse Tyson. The most important thing is him as a student or him as a person and their curiosity. We tend to get like caught up in, what am I using, Zoom or Google Meet, or what am I using? We get caught up in the tools and we forget that the most important thing are the people. And so in my long teaching career, I've only seen one innovation, and that was the internet. And so when the internet came out, I fell in love with the internet and put a bunch of videos out. You might know me from Bozeman Science. You've seen me teach a ton, and some of you are maybe using me in your classrooms as you go remote. But that was transformative. It was an innovation that has really changed radically what it is to be a teacher. But I want to tell you a little bit about my role, and that is that I'm not teaching anymore. For the last 6 years, I've been a consultant working with teachers all around the world as they implement the next generation science standards. And so as a result of that, my files have grown way larger. And so I started a website called The Wonder of Science. And I have a really cool announcement I'm going to make at the end of my 20 minutes here that will eventually be there. But to specifically dig into today, I want to frame today around this idea of innovations and constraints. And so I want to show you, I'm a biology teacher at heart. I want to show you a pretty cool phenomena. This is called the megaplate from Harvard Medical School. And what they did was build a massive Petri dish. And so on one side, it's 2 feet, it's 4 feet long. And if we look at it and then turn that whole thing on end, you'll see that at the end, there was an area where bacteria could live. There was no antibiotics on the end. But then as you move forward, there was enough antibiotic in that first region to kill them, then 10 times that amount, then 100 times that amount, and then 1,000 times that amount. And so think of it like a football field where it's harder and harder and harder to get to the middle. And so if we look at how this phenomena plays out, if we just do a time lapse of bacteria growing, what you'll see is there's going to be a bunch of bacteria growing on the end, and then they stop. They hit this constraint. They can't go any farther until a mutation shows up. Think of that just like an idea. And that spreads to all the bacteria that grow from that. And then we see new mutations and new mutations. And over time, bacteria are becoming more and more resistant to that antibiotic as they move towards the middle. And eventually you have bacteria at the middle that are resistant to 1,000 times the antibiotics of a normal bacteria. And so that's evolution. What you've got are all these different threads. But if you also look at it on the right side, all of the bacteria came from just that one idea. And so I'm going to use this. It's a really cool phenomena to use like in a biology class, but I'm going to use this as a metaphor to explain what we're going through now with COVID. And that is what we, and I mean we as science teachers, are going through. So the first big constraint that we had was schools have to close. It's not safe for us to be close to each other. So like we have to be teaching remotely. And that was hard. Like that was a struggle, and some of us are still struggling with that, but we did it. So we made it through, and there were some ideas, innovations that came out. If you remember, Zoom is one of those that just, I'd never heard of Zoom, but now everybody's using Zoom. It's an innovation. But what do we have ahead of us is we have a lot more constraints that are coming. The next one would be, how do we make science authentic when we're not all together? In my last Science is Cool conference, I tried to share data sets and how we can use data sets that are out there and phenomena videos like the one that I have here so that we can engage into it. Also, I just see this in the chat right now. Everything I'm showing you right now, that my Google Slides will be available later, so you could even use this as an analogy if you want to. So right now, I think we're in this area of how do we make this authentic? How do we bring our science classroom to the students, no matter where they might be? This is what I'm hearing from a lot of teachers now. Okay, how do we assess students? How do we give them a grade? How do we report out on that? Districts are having to decide that, and there's a lot of tension going on. And I think we're not even thinking about the biggest constraint that's coming, and that's going to be the fall. Like the fall, we're going to have to do science instruction with a brand new class who we haven't met. How are we going to build those relationships? How are we going to like get them excited about the science that we're doing where we might not even be together? And so I think the key thing that I want to show you is that we can learn a lesson from evolution, and that is you can't just sit there and wait for it to happen. Like you have to make the changes. I hope I show you some things today that will change your online or remote class tomorrow. And so the topic I called this, or the name of the speech is Let's Innovate, Next Generation Science. When I heard Neil deGrasse Tyson talking about like what a science classroom should be, not a body of knowledge, but it should be about curiosity, I was really yelling, preach, preach as well. Like that's so important. It's not about like a body of knowledge. That's not our job anymore as science teachers. Our job is to get kids curious and get them asking questions. And so I want to give you some tips that have helped me. First thing is your presence online is incredibly important. Like I'm trying to get the lighting right. I'm trying to look good, and I'm trying to really smile and look at the camera as much as I can. Why is that important? Like this is our classroom now, and it may be our classroom on and off for the next few years. If I were to look at like what's in my background, changing your background even to say like my background is, let's say I'm in a science lab now. And let me see, I've lost control of my computer. So let's see. So even as we move on, I want to show you just one more thing before I show that. So as we move online, like just having a science lab in your background can help, or even showing your science classroom in the background, that would be important. But these are two things that I've learned since the last Science is Cool conference. And the first one is that a whiteboard and something to show that whiteboard from is really, really important. So I purchased a document camera. A document camera is used by elementary teachers everywhere, but the great thing about it is I can point it down at a whiteboard that I got at, I think, like Office Depot. It becomes your whiteboard, and then you can share that with your students. And so like you have to start imagining your classroom is your science classroom. It just happens to be remote. You can also move physically where you are. So I'm gonna pick up the camera for a second, and just move it over here. So it's in a different place. It's next to my science lab. The configuration I'm gonna show you though is this configuration. So I'm moving the document camera back, and it's just aimed at an angle. And what I'm trying to kind of do here is my favorite part of teaching science. And that favorite part is, when you get kids around a lab or on a lab desk and you just like show them a cool phenomena, or you show them some kind of a demonstration. The key thing I think that we need to do is like, and I think Neil said this as well, like don't explain first. Like give them something to look at and give them something to play with. I think that's the most important thing. Just give them that a little bit of time so they can do a little bit of curiosity. And so I'm going to show you what I've got. So I've got hopefully you can see this. This is a famous phenomena. These are called the Dippy Birds. And so we're going to dig into the Dippy Birds a little bit. The one thing I would love that you wouldn't do is, if you understand how this works, could you not jump on the chat and impress people with how smart you are? Like, we're going to try to work through this as a group and figure out how this works. And so if you know the physics of how this works, please don't share that with anybody. I want you to just kind of go into teacher mode, but the rest of us are going to work together. We're going to try to figure out exactly how these work. Now, I think as we do that, I want to use a card here that I think is really important. And this is called the phenomena card. So what we're looking at right now is a phenomena. A phenomena is something that occurs in nature. And so what we're going to learn about is a phenomena. There's important science that we'll learn together as we do this. I chose this because I want you to learn a specific science thing, but I'm not going to tell you the science first. We're going to dig into it to figure that out. Now, if you've taught science like me, we've called these demos in the past, or discrepant events. The cards I'm using here are called inquiry cards, and you can find them on my website as well. But this is what we're going to learn. And the key thing is, you don't want to kill the wonder. Like, don't tell them how it works before you actually look at it. They're not scientists anymore. They're just simply listening. You're just talking, you're not teaching. Teaching is getting them to engage in a phenomena and figure it out. What are we going to do? Right now, we're going to do an observational investigation. And so I'm going to need your help a little bit. And so if you haven't found it yet, I would love if you would find the chat, where that chat is. But what we're going to do is we're going to start to observe and put our observations in the chat. And so what I want you to do, why is this a phenomena? I set these birds up last night, and I came out this morning, and they've been going all night. So for like 12 hours, the birds have just been dipping, and they'll continue to dip today. But could you, for a second, be a student? This is how I do it when I'm teaching online, is I have the kids start to put their observations in the chat. So somebody just said that the fluid is rising up the neck. So I don't know if you're noticing that. Let me zoom in a little bit. So somebody noticed that right up here, that blue fluid is moving up the neck. And so I think that's most important. One person just said that they don't drink at the same time. Pam Stewart said when they touch the water, then they keep going again. It looks like Mark Peterson said one of them is going faster than the other. Donna says that their beaks are getting wet. Somebody says they don't touch the water when they go all the way down. Wait, it's just changing, somebody said. Somebody said the blue liquid, it's hard for me to read this, the blue liquid has a higher level. It's a really good noticing. Let's see. I think it was Debbie said, Debbie's really interested in the tail. And is the tail important? Like, what's the function of the tail? They bob and they go up and down. Red is moving faster. Now, what I would say to you is, like, I haven't really told you how to think about it. You're doing a great job already. But what I really want you to do is start looking for patterns. And patterns in science are going to be patterns that are different than patterns we might have in math. Patterns are like anything we see, anything we hear, anything we feel. Now, I hope you're seeing what I'm doing as a teacher. I'm trying to bring you into the lesson itself by saying your name and then trying to read what's going on in the chat. So Samsung said that it keeps going over and over and over again. And so this is called, and it's a really important thing in science, it's called an observational investigation. That's when we just carefully observe and we try to figure out the phenomena. We're not trying to like tell people what we think is going on. That's called your explanation, and that's going to come a little bit later. Right now, we're just trying to figure out like what do we observe? The next thing I would like you to draw your attention is the most important thing in science, and that's our ability to ask questions. And so what I'd like you to do is come up with a question you have. What are you wondering? So for example, I just saw Carol say, what is the liquid made of? Is it gravity? If we have other panelists on here, like Dave, I know you are on here a little bit, Dave, if you wouldn't mind like taking your video off and unmuting, and so that we can kind of like model. Hey, Dave, how's it going?
Hey, Paul.
Hey, Clifton, how are you doing? So
Great.
this really makes my heart sing when I'm a teacher and I'm teaching online. When I see the faces of my students now start to appear. Ariel, it's great to see you. Chris, it's great to see you. So if you know how this phenomena works, please don't just like ruin it for everybody else. But what questions might you have as we watch the Dippy Birds dip over time? Dave, do you have any kind of a question?
Yeah, there's and I think people are seeing in the chat, the blue water, the red water, they're going up the neck, and it looks like once they get to a certain point, it tips over and takes a drink of water.
Right. Gotcha. What about you, Clifton? Anything you're wondering about?
Yeah, does this work outside? Or what if there's a really hot day or a really cold day? Would this would this still work?
Yeah, I did, and this is not a setup, but I used the PocketLab and I was just hooked the sensor up behind Clifton, and it was just going back and forth. So you can see the oscillations there, and then there's the big dip. I don't know if you're seeing that. So it looks like about a 30-second time. Then I put it outside, and when I put it outside, it goes like, we could call it like those little dips and the big dips. They got really compressed, and so it speeds way up. This was kind of yesterday there. But I don't know if you're kind of picking up on what I'm doing as a teacher. I'm trying to put you in the position of the scientist as you start to figure that out. What are some other questions that we might have?
Is the liquid color getting into the clear glass?
Yeah, is it going all the way up here? Is that what you're saying?
Sorry, they're dipping into the water in the glass. Is any of that food coloring getting into the water in the glass?
Oh, that's let's zoom in. Yeah, so let's see if I can zoom in a little bit. No, it looks just as clear as it was yesterday. It's really good wondering. Now, I hope you're picking up on the teacher moves that I'm doing. Like, I know how this works, but I'm not telling you. I'm just kind of playing along with you. And I think what makes that a compelling way to teach is that you're in a position of a scientist now. And so at this point, like Chris, I see you, Chris. So if we were to go to the next, let's just do an experiment. The cool thing about this is I've got her in my house, so let's do an experiment on it, Chris. What would you have me do if you want me to do an experiment with the birds as they sit here?
Oh, I had a question, actually. My question was, I see them behaving in a way that when I see a bird put their head in water, I assume they're getting something from the water. Are they actually drinking? Are they bringing? It's
such a good question. Like, yeah, I think we could maybe look at it. You're almost saying like, is the bird a closed system? Is it like, is stuff go into it or not? We could look more carefully at this if we wanted to. This is something cool. I got a digital microscope, so you can use a digital microscope and we can look more carefully in. So Chris, that might be a cool investigation we could do. Let's see if that works for just a second. Let's go here and switch to so let's see. Here's my USB microscope. So let's look in the head. So we're gonna put this, so we're looking at the head of the microscope. So this is that red on their head. Are you seeing that okay, Chris?
Yeah, that's kind of freaky looking, to be honest.
It is freaky. This is really freaky, Chris. I was looking at one that's dry, and this is what it looks like when the head is dry. Here's another bird. Can you see that? Oh. Totally different.
Yeah.
Looks like fibers that are getting swollen.
Isn't that wild? Yeah, it looks like some kind of a fiber or something. Yeah. Let me switch back to this view for a second. It looks like there's a dead bird back here. So the idea of how do we start to do experiments online, I'm trying to model that right here. Like, you are my students. I'm looking at your faces. You're looking at the phenomena, and we're trying to figure this out together. Clifton, Dave, do you have any other quick experiments that we might want to do with these birds as they're sitting here? What would you do?
Well, I'm wondering if there's no water, would they just sit there and stop?
Yeah, somebody said that in the chat. Take away the glass of water. Alexandra Ellis said that. Will they continue to dip if there's no? I don't know. Are you seeing that? The blue one keeps going. So yeah, they'll keep dipping. Is the water cold? What's that?
Can the head be removed?
It can't. Yeah, and so I've taken these all around the world, and I'm pretty sure it's a sealed container. It looks like if I were to use a flashlight, I could maybe shine a flashlight in the back through its head, and you might be able to see a little bit more. I think it's just like maybe just a sphere that's kind of sealed, and then the material's kind of going in it. Does it have anything to do with humidity, somebody said? Put water of varying temperatures in. I think that would be a cool experiment we could do. So I've got like really hot water back here. So somebody's saying, let's put some really hot water in there. I don't know if this is still hot. Oh yeah, that's hot. So we could put hot water on the one in the back, and we can see what might happen with that. What about if you put different weights on it? That's a really cool idea as well. Is it liquid pressure? If we put them in a vacuum, what might happen? I hope you're seeing what's going on in the chat. Like, this is what science really is. Science is not about learning things. Like, I was a scientist for a little while, and let me tell you what a good scientist is. A good scientist is somebody who asks questions that no one has ever asked before, and finds answers to those questions. Observe scenes that they've never seen before. I don't know, did anybody pay attention on what it was doing in the hot water yet or not?
It hasn't done anything. I wasn't
watching it. Gotcha. Oh, that's weird. It's just kind of sitting there. Huh. Like what we eventually would go to, if I were to put another card up here, is we are engaging in argumentation from evidence. So like we are gathering empirical evidence by watching this. It's really interesting. I'm kind of interested in just this bird in the hot water to see what happens.
Hey, Paul, I was actually wondering if you did travel with these, if you took it out in an airplane while you're up at altitude, because it's a much lower.
How that might affect it?
Yeah, that'd be interesting.
It's really cool. This is wild. It won't drink. It's not drinking the hot water. It's like rejecting hot water.
It does not like coffee.
It doesn't like coffee. Yeah. This is another thing that I grabbed. Let's see if we go with this to go to other data. This is data I looked yesterday. I got a thermal imaging camera. So a thermal imaging camera, I got one from FLIR. You just stick it on the bottom of your phone and you can start to get thermal imaging. And I think like if I were to give you all pieces of advice, like a lot of us are not thinking about like necessarily things that we can't see. And I would say this to you, the panelists, and to the people who are in the chat as well. Like what makes this phenomena phenomenal is that it's really, I mean, to really get to the specifics of it, it's really about energy. It's like about energy and matter. And to build on what Clifton, I think, said earlier, I think it was really, really important. My role as a teacher is to point out, hey, nobody's asked any questions about energy. This seems to be violating fundamental laws of energy in that like it keeps going and going and going. It's almost like a perpetual motion machine. So like my role as a teacher is to get students asking questions in specific areas. And so all of these cards that I'm showing you is on my website called The Wonder of Science. What I want you to know is I didn't make this up. Like this is the next generation science standards. And so when Neil was saying, why can't our classrooms do more of getting kids curious and trying to understand the world? Like we're doing that. We're trying to do that. We've been teachers who have been working on the next generation science standards have been working on that for the last 5 or 6 years. Like we always began lessons with some kind of an engaging phenomena like this, and then have the students engage into that in a more deep fashion. And so I know that Dave, I'm maybe out of time, and so let me stop sharing that for a second. Like I hope you picked up on one thing, that I never told you how it worked. Like, I didn't tell you how do the Dippy Birds work. Like, that's not our job as teachers. Our job as teachers is to help students figure out how that works. And I got to tell you, like, if you Google how the dipping bird works, you're cheating. You're just looking up somebody else's inquiry on the internet. You're not a scientist anymore. You're just trying to figure that out by looking up somebody else's answer. And that you have to tell kids too. Like telling them what you do in science classroom is not just look up the answer to questions. We're going to figure it out together. And I found like tools like PocketLab and other like tools like this document camera or video physics or just your phone, your cell phone. You can do so much. I think that's the key to getting kids to understand that. One thing I just saw in the chat is really, really important. And that was like, I don't have a Dippy Bird. How do I do this? Well, you can use a video of a Dippy Bird. I've got all my slides and you could look at those and all the data that I collected. You could do that. But I think sometimes when we're looking for a phenomena, we look too, like we don't get what a phenomena is. Like a phenomena is something in the world that happens that we don't understand how it happens. And so grab a plant from your backyard. Like look at the sun and how it changes like something going on in your house at a time. Or like I just took my digital microscope and filmed the underside of a leaf and it's just magical. Like the cool thing is that if you have it in your house as a teacher, then the students can ask you to do labs and then you can do those. And you kind of end up acting out those. I think, Dave, I know there might be some questions. Can I announce one quick thing?
Yes, Dave,
and that is that this is wonderful. Thank you so much for letting me participate, but this is not the work that I do. The work that I do is small workshops with like 30, 60 teachers, and we get together and we dig into topics like this for a long period of time. And so what I'm doing is next Thursday and Friday, I'm offering 2 free science teaching workshops. They'll be like 3 hours. We're going to do it on Zoom. We're going to get in and show how to do modeling and argumentation. If you want to come, it's totally free. You'll sign up on The Wonder of Science, and I'm sure we'll have a waiting list at some point. But I do want to I want to give back to teachers, and I've got resources and things, but the most important resource is me. And so I want to give that to teachers, and also I want to use it to learn a little bit more how to teach this way. Dave.
So Paul, by the way, that was fantastic. Thank you. And I do have some questions I want to ask you on this. And I'm going to, a lot of people were just as interested in the tools you're using as opposed to the lesson. Right. I know that's what you're trying to do.
Yep.
You have videos on your website that could show off these tools? Yeah,
so if you go find where to sign up for the workshop, I have teaching resources with lots of videos showing me how I use that and how I use these cards and how to dig in, for sure. I'll put a Google slide deck. It's there right now, and it has all the slides that I just had, but I'll add another slide where I put all the technology. So if you want to see like, what did he use? I'll put that there as well, Dave. It might take me a little bit to update the Google slides.
You know, what struck me as you're doing this is, as a science teacher, you have to have some additional tools other than just talking to the students to do this, you know, to actually teach science remotely. But you can if you have a few tools.
We got to get ready for this fall. I mean, teachers, I can't say that enough. Like, we have to, if you get into your schools, get some of that home. So like, when you have to have a remote teaching plan so that we can do that. And also, I know this, like last time I learned this in the Science is Cool conference, like, don't use a Zoom to sit and read PowerPoint slides. Like, that's not the role. Make a YouTube video of that. Like, this time should be time to interact with your students. Like, the one thing they need is that face-to-face action. Use these synchronous times to engage in inquiry, and leave that boring reading of the PowerPoint somewhere else.
Yeah, exactly. So that's what we learned too, is how you actually do it is as important as the content.
For sure. Yep. Yeah, and I think it also is important to just use the chat. Like, all my good teacher friends are using technology like Peer Deck, Nearpod, like Google Forms, all of that to interact with your kids. I think it's really important that we understand this is our classroom now. And also, Dave, to build on what you said, we're going to go back to school, and I hope we all just don't go back to the way we've done it in the past. Like, I hope we can use these really cool technological tools. Can you believe this? There's 10,000 people. The number of people who would go to NSTA are just listening to you and I talk. Like, unbelievable. And so we can't just like go back to normal. We have to leverage this to move in a cool way.
You know, we around the office, we've been talking about this all the time. Had we not been in this pandemic, we would have never thought of this idea of getting people together virtually, and probably the people wouldn't have come. So this is a good example of how you can use technology, you know, in a unique way in this, you know, these very uncertain times.
Yep. Somebody asked this. Yeah, it sounds like the sessions are filling up. Thursday and Friday, we're going to do it 2 times. So Thursday and Friday will be the same thing. So you wouldn't want to sign up for both. We're going to try to figure it out on Thursday. And if there's, just like you found, Dave, like if there's there's a need for this, if teachers need this, like to dig in and do workshops, like I'm up for doing like more in the future. I think, yeah, it's a really cool time, a time that we can all kind of come together and help each other out. But don't wait, like innovation, to tell Dave, just to reflect a second, when I started putting videos on YouTube, this is 10 years ago, it felt exactly like Zoom feels now. Like we don't know how to use this platform. We're all figuring it out, but we know it's going to be a big part of what the future looks like.
Yeah.
I don't know. Cut me off, Dave, when I'm done.
No, exactly. That's great. Hey, just the last thing, and we want to go to a break, and I want to bring Chris on. He's going to talk about the credits. So Paul, where do people find you? You have the website, The Wonder of Science, but your YouTube channel is still Bozeman Science?
It's called Bozeman Science. Yeah. And I just made a video on moving online. I'm going to make a video that's very similar to this that I'll put on Bozeman Science. So just think of it like Bozeman Science is me, like that's who I am kind of. And then Wonder of Science is where I put all the resources. So that'll go there. That's just like that old file drawer when I used to teach. It's back in the day. It's all the stuff that I've made and other people have made. Also, yeah, Twitter, social media, wherever you want to find me.
So I just wanted to point out, so I went to Bozeman Science. So we have about 10,000 teachers here who signed up for this. You are just about 10,000 short of 1 million subscribers. So if everybody here goes on and subscribes to Bozeman Science, which I highly recommend, is a great channel, you're going to put Paul over the 1 million mark. And we're going to have to celebrate.
That's right.
We'll have a Zoom celebration.
Celebrate. Yeah. It is like, think of this to teachers too. Like I'm just sitting in my dining room. Like what an amazing time. Or when I made the Bozeman Science videos, I'm just sitting in my room making stuff. Like teachers can change the world. They really can if they're willing to like figure this out and then also be willing to just share it with everybody else. I hope you pull that, teachers who are watching. I'm talking specifically to you. Like you're the most important thing. Your learning today and your learning this summer, next year is the most important thing you offer your kids. And also like, what do they need now more than anything else? I've seen this in all the Zoom classrooms I visited. They need social emotional help. Like they need somebody to say like, I care about you. And Dave, thank you for putting this together, PocketLab, because that's why everybody's coming here. Teachers need social emotional help. Like we need that connection. Teachers by nature are social. And so I love that you're trying to keep this conversation going and super appreciate the work you've done.
Yeah, that's right. So Paul, we'll see you on the Facebook group. You know, there'll be a great place to reach people. So you're definitely a key member there, and would love to do that. I want to leave you with one last funny thing. You got a bunch of nominations in case you want a political career to be Secretary of Education, by the way.
No, but go ahead.
But we need you.